How do null values undermine type safety in programming? Imagine a world where your code promises to always give you a valid number or object, but suddenly it hands you nothing at all. That's what null values can do to your program's promises. Null values are like empty boxes that say, "Nothing here." They are used to show that a variable has no data or object assigned. But when your code expects a real value and gets null instead, problems happen. This breaks what we call type safety. Type safety means the language makes sure variables always hold the kind of data they are supposed to. For example, if you have a variable declared as a number, it should never hold a string or null unless you say so. When null is allowed freely, the variable can hold nothing, which is not a valid number or object. This creates a risk. When your program tries to use a null value as if it was a real object, it crashes. These crashes are known as null pointer exceptions. They happen because null is not an actual object, so trying to access its properties or methods causes errors. Debugging these bugs can be tricky. Null pointer exceptions often show up from where the null value was first assigned. They can propagate through your code, making it hard to find the original problem. Modern languages try to fix this by making null safety a priority. They make variables non-nullable by default, so they cannot hold null unless you explicitly say they can. When you declare a variable as nullable, you mark it with a special symbol like a question mark. This tells the compiler that null is allowed, but you must check for null before using the variable. This way, null pointer exceptions are less likely to happen at runtime. Instead, the compiler catches potential null issues early, during the coding phase. This makes your code more reliable and easier to reason about. When you adopt null safety, you reduce bugs related to null values. Your code becomes clearer because you know exactly where null can appear and how to handle it. This helps you fix bugs faster and prevents crashes. In simple terms, null values undermine type safety because they let variables hold an invalid, no-value state without warning. This breaks the guarantees that your language's type system provides. Modern languages with null safety features restore this trust by making nullability explicit and requiring you to handle nulls properly. This approach keeps your code safer, more predictable, and easier to debug.